So,
Hi
good
there.
morning, everybody.
Hi, Lucas. How are you doing this morning?
Good. How are you doing, Peter?
Not too bad. We'd just like to welcome you all here to our Twitch demo that we're hoping to get some nice engagement with all of you. We're going to take you through some of the aspects of GitHub Actions and using it to automate your application deployments and possibly cloud-based infrastructure. I'm a solutions engineer working in the UK for GitHub. And Lucas?
Yeah, I'm a solutions engineer as well, working with Peter in the same team, but I'm located in Germany.
So today we're going to start off taking you through some sort of like basic fundamentals. We're going to build up a couple of examples as we go through this live stream, and show you really what's possible with GitHub Actions and the sort of flexibility and what you can do with it to effectively power your ability to deploy your software projects into the cloud. So we're going to start off today's demo by looking at maybe automating some AWS infrastructure. And for this, we're going to use Terraform. Now, we could use other technologies and that, but we've chosen Terraform for this level of automation because it allows us to fairly easily describe some sort of infrastructure constructs. Now, this is a little bit contrived. There's no sort of applications here, but it's just to fit within the boundaries of what we can actually showcase in a reasonable time frame in the demo. So we've got a Terraform module here that is called AWS Infra, which is going to create some infrastructure for us. We pass in a few variables, and we're going to output the name of the VPC ID when we're finished deploying this. So if we take a quick look at the Terraform module here what we're creating, I'm going to create a VPC, an internet gateway, some subnets, and some route tables, and then associate those route tables with the VPC. So this would be some very simple low-level bootstrapping of an AWS environment that you would then potentially start to leverage to then deploy your applications into. So for these particular workflows, we've written some GitHub Actions workflows to actually go about creating these for us. And
should we maybe explain a little bit the action workflow in general for those who haven't used it before?
That's good. Would you like to delve into that for us, Lucas?
Yeah, of course. So in general, what Peter is going to show you with me is how to use GitHub Actions. And for those who are new to this platform, it's really cool because GitHub Actions is a little bit like if this then that for developers. So you can take any event on GitHub. So like you can see here in the workflow, this on event, and then we can use this as a trigger for a set of actions. And these actions can be stuff that you do on your command line. It can be actions that other people defined, for example, like the folks at HashiCorp with Terraform. So you can just leverage their Terraform tool within your workflow without having to set it up yourself. And then you define also a sort of set of rules or things how they should interact, these actions. The cool thing is you don't have to care about how to execute it, because what we define with this runs on snippet is the place where we execute this action. So this could be in a hosted environment that GitHub provides. And the nice thing is you get these for free with every GitHub account. So you have a set of minutes you can use every month. I think it's at least 1,000, Peter, for the free account. So you can get started right away. You can use an environment in Linux and Windows and Mac. And the cool thing is you could also run it on your own hardware with a so-called self-hosted runner. And what we will today is use some triggers, some manual triggers that we have here, as well as could be some events that we will use, like a deployment event. And then we will act on these events by defining, for example, the Terraform logic that should be executed or other things that we want to do to manage a cloud environment. So Peter, do you want to guide us further?
Certainly. Is that big enough? We saw in the Zoom chat, the Zoom chat, sorry, the Twitch chat that it wasn't big enough. Is that good now? Great. So continuing what Lucas was alluding to with the events that we're listening to here, we're using a workflow dispatch in this context, and workflow dispatch is our manual trigger. But the great thing about a workflow dispatch is that we can provide inputs and defaults to help us along the way, hold our hands through this type of manual triggering. So here we've defined an application name and an application environment. We've stated that both of these are required. So we can't execute this run without actually providing a value for either of these. And we've provided a couple of defaults. So for the application name, we've called it Twitch. And for the environment, we're going to default and call it dev. Then we have a job declaration. Now, a workflow can be made up of multiple jobs, and the jobs can either potentially be independent of one another and all run in parallel, or you can actually create chaining events using the needs syntax, which allows you to connect the output of one job to another job, which then allows them to be sequential and pass information between them. In the cloud-hosted environment, when a job runs, it will run on a dedicated cloud runner, and that will be destroyed at the end of that job. So if you had job chaining and you needed to pass information or build artifacts between them, you would need to potentially store those either in an artifact cache or have like jobs publishing images to a container registry, for instance. So coming back to this, we're going to execute on Ubuntu, and we're going to pick the 2004 image that is provided for us. There's also Ubuntu latest, or you can pick like 1804 and 1604. We're going to set some common environment variables here, and these are for us to interact with our Terraform processes, but also we're injecting our AWS credentials necessary for us to actually interact with our AWS account. And here you can see that we're using GitHub secrets for this. So these secrets are potentially either stored on the repository or they're stored within the organization. And you can set constraints on the organization as to how you decide to actually go about sharing those secrets. So we'll come back and take a look at the secrets in a moment after we've just finished describing this workflow. And then these two other Terraform variables here are taking our workflow dispatch inputs. So you can see here we're using the GitHub context, and we're looking at the event, and the event for us is workflow dispatch. It has an inputs field, which will be given to us, and we're grabbing the app name. So this is how we're actually taking the manual steps, so manually provided input as when we invoke this, and applying it to some environment variables, which are then passed into each of the steps that we execute. So first of all, we're going to check out the source code. So that's going to be our repository with our Terraform module in it. We're going to leverage HashiCorp's setup Terraform. And this is a community provided action step by Terraform, and this allows us to actually specify a version of Terraform that we want to install on our cloud hosted runner. In this case, we're going to pick 13.3, and we're going to put a wrapper around the Terraform executable, and this is an actual nice little feature which then allows us to access the output standard error and some output variables as part of the runs. So when we invoke Terraform, it's actually nicely integrated into the GitHub Actions outputs and that for steps if we wanted to reference those values. We're not doing that in this particular case, and if you were going to do that, you would have to assign an ID to the action step that you're actually wanting to execute. Because we use Terragrunt, and we're using Terragrunt here to actually just do some injection into our backend store, because we're using S3 and the DynamoDB table to actually preserve our Terraform state in these executions. So we're using Terragrunt here, and we're wrapping Terraform and Terragrunt to actually do some low-level wiring, and then actually execute our Terraform workflows. So it's just the standard Terraform approach of like init. So this will go and download all our modules and initialize our Terraform ready to be run. We're going to validate it, so just make sure that we don't have any mistakes or anything in there, and it's not going to fail for any obvious reasons. We're then going to execute the plan phase and save the plan locally to Terraform plan, and then we're just going to nonchalantly just power through and apply that plan without waiting for anybody to review it.
Okay, so before we continue, Peter, can you elaborate a little bit why it makes sense to use a tool like Terraform in that context?
Terraform allows us to potentially encapsulate sort of logic and make it reusable and composable. So in this particular instance here, we've got it's all contained within the repository, but we've got a module that defines our AWS infra. So in theory, we could extract that and actually reuse that in other projects. And the benefit there is also, instead of going sort of low level and maybe using AWS CLI or manually clicking around and creating snowflake environments, we can define a pattern that works for us, whether it be our company or us individually, and get consistency and repeatability on those environments that we want to create.
So Drago also said that he's using Terraform, but he hasn't heard of Terragrunt. So can you maybe give a tip to him why he should use it also maybe in the future?
So Terragrunt is an interesting utility. You can use Terraform very happily without using Terragrunt, but Terragrunt is more focused around what they call the dry approach, do not repeat yourself. Mm-hmm. So it has a lot of extensibility and reuse power. So if we look at the Terragrunt HCL that is defined here, what we're doing is we're defining a backend here, which is an S3 backend, and we're going to generate this backend.tf file that we can use on our workflows, Terraform workflows here, and we can define what the actual configuration is in. So what we're doing here is we're leveraging the environment variables that we're setting to give us a unique key. And the reason we're using Terragrunt here is that you can't use variables in the backend state with Terraform by default. It gets very complex to actually try and inject this type of information in. And because potentially the way that we're going to run this is that we might have multiple states that we want to capture here. So I might want to deploy a dev environment, a QA, and a prod environment all out of this repository. This key would be shared between all of those environments. Now, that means that if I create prod, it would destroy dev. Or if I create a QA and I had a dev environment, dev would be destroyed and replaced by QA. So this gives us the ability to actually have a flexible environment per what we've got here, which is an app name and an environment. So the combination of these two parameters here gives us a unique key, which means that we don't keep overwriting our state. So that's effectively all we're doing here with Terragrunt, is to give us that level of injection. So I said we'd have a quick look at the secrets. So if we come back to looking at the secrets, on this repository, I've physically injected no secrets. So there are no secrets specific to this repository. And then here you can see the AWS access key and secrets key are shared by our organization. And if we go and take a look at our organization, whilst this particular workflow only has access to those two secrets, you can see that we've actually defined a lot more within our organization. And this comes down to how we decide to share these types of secrets. So if there's shared context, then an organization makes a great place for storing these secrets. But you may want to actually control which repositories gain access to them. So you could think of like a development team working in an enterprise. There's potentially some very sensitive deployment secrets that you only want to restrict to maybe one or two workflows or people that have access to them. And so you can leverage that type of granularity by limiting as you can see here, we've got these limited to individual repositories, whereas these ones are shared across all private repositories. And you can always go in and update these to the various options that you want. So you could share it with all repositories that live in an organization. So that could be something that you're not particularly too concerned about being leaked. Or you can go down to the specifics of like individual repositories here, where, sorry, with that selected, you can actually select the individual repository so that you actually want to share that with. So this gives you some control over the potential leak or blast radius if something like this was to leak within your workflows.
Could a colleague now, or like a apprentice, or somebody just go in there and get the secrets if you want, or lock them to the prompt?
So the settings for the organization, you need to be an organization admin to be able to actually modify the scopes for those particular secrets. So any secrets that aren't shared with a repository. So if we, as we can see here, this particular repository only has access to these two secrets. So in any action run that can be executed, these variables need to be accessed using expression syntax, which is the $bracket secrets dot, and then the name of the secret. If you don't even reference that, you don't have access to these secrets. So you explicitly need to have defined these in your workflow to gain access to them to begin with. And then any secrets that aren't actually expressly shared with the repository just aren't available. You don't even have knowledge of them being there within the actual workflow. So we have protections in that space. But do keep in mind that if you do share a secret with a repository, there is a potential for it to be exposed. So make sure that you have a plan in place for secret rotation and good protection mechanisms that you would try to apply to things that, rotation, like you should probably rotate like these secret keys and access keys every 30 days, for instance. For more short-lived or highly risky secrets, you might actually only want to have them preserved for a week or something to that degree. But it's really up to you as to what you're actually trying to achieve with those secrets.
And the cool thing is we can also integrate with a tool like HashiCorp Vault. So if you have like an existing secret management solution, it's quite likely that there is an integration already for Actions.
Yeah, we integrate with a lot of third-party systems in that space, and even things like Mozilla SOPs, secret management systems, GPG keys, Ansible Vault, HashiCorp Vault. I've seen integrations with CyberArk. There's effectively any secret management system could potentially be integrated with. So if we come back to actually trying to run some of this infra, so we've got this AWS create networking infra. This was the workflow that we looked through. Because we've got the workflow dispatch button there, we can see that we've got this run workflow. So if we click on this, you can see that we've got Twitch and Dev already pre-populated for us. We can just click the run workflow to accept that particular defaults that were provided for us. And in a moment, we can see that our workflow is now queued. And we will watch this one go through. So we've checked out the sources. HashiCorp Terraform and Terragrunt have been installed for us. We're now running the initialization for our Terraform. So that resolved our modules. We've validated it, so we had no errors. A plan's been generated for us here. And if we scroll down, we can see that there's no changes because this already has an environment present. And of course, this apply does nothing because it already existed. So we've successfully created an environment that was already there. So if we decide now to create let's say a QA environment.
Nice.
So let's see, with some different parameters, we should get a actual change being made to our AWS infrastructure. So here, this time round, you can see that the plan's going to, if we expand the plan aspect here, we can see that it's actually going to make some changes. One of the really cool features of GitHub Actions that's just recently been made available to us is this new log rendering. And you can see that we actually get colors in here now as well. So in the past, you had to suppress colors and turn them off because they wouldn't render. But now with GitHub's just recently improved this log output, and we can now actually get colors from like terminal commands and emojis and things like that that are part of the outputs of our applications, which is a really nice feature that we've just recently added. So we saw that Terraform applies things. We had an output, and we can see our VPC output here. And then this output would actually be available inside an action step output for this particular workflow if we wanted to leverage this in other action steps. We're not doing that in this particular case, but because we use the Terraform wrapper, this output would be available to us to access. And now if we jump to our AWS management console that we've got here, let's have a look at the VPCs. And we can now see that we've got a Twitch QA VPC that's been created for us. So we've successfully, and the IDs here should match, which they do. So it isn't smoke and mirrors. And there's a particular action workflow for creating some AWS infrastructure. Now, one of the interesting things you might note here is that we had this extra run that's this run completed, and we've added this into here to showcase a relatively new workflow event that allows you to chain workflows together. So called workflow run. So this is just showing you a proof of concept as to what you could do if you had like workflows that you wanted to chain together. So say for instance we have a workflow like we've just done that creates a VPC. You might then want a secondary workflow that then maybe starts building out something like a Kubernetes cluster or an EC2 instance or some other kind of aspects to your infrastructure that you might want to leverage. So we're able to listen to the workflow. So we just executed the AWS create networking infra workflow. And we can specify branches that we want to listen to. Here we're only working off the main branch, but you could imagine if you had pull requests or things like that, maybe you want to execute this only on the pull requests, or you only ever want to execute on main, depending on your workflows and what makes sense for you. And we're only listening to completed events. You can also be notified when any event, when any workflow starts, and you'll get information about the workflow. And here we're just exposing some information about the actual workflow payload. So if we take a look at this, we can see that the workflow payloads. I can see that the original workflow was a workflow dispatch. It executed on main. I was the author on the head. There that actually executed. You've got links to the repository, for instance, ID for the job that was run, so on and so forth. So you can potentially use this information to pull back information about the job that ran before it, but you can then leverage workflows and chain workflows together end to end using this type of approach. So let's talk about Terraform Destroy. So say we're actually now finished with our workflow. We have a dev and a QA environment. So let's destroy the QA environment because that's the one that we just created. So we're finished with it. We're no longer interested in using it. I'm going to invoke the workflow for that. And
there's a good question, Peter. So Drago is asking, can we get like outputs from the create networking workflow in that completed workflow? So could we share them between workflows?
So you can share some data across those boundaries, but you would actually have to go back and use like our APIs to query potentially the logs, or use some other kind of API construct to pass information between. So when you're chaining two workflows like that, you only get notified of what potentially ran before it. So the emphasis would be on you to actually use our RESTful APIs to then query the job specifics. So it could be action steps and things like that. So our RESTful API is quite expressive in that there are limitations on what information is available to you, because of course, there could be sensitive information exposed in that way. So there are other alternatives available to that, where you could potentially capture the output, put it in an artifact associated with that workflow, and then pull that back. And I'd say if we just table that for a moment, because we will come to sharing artifacts between workflows as an example of a more advanced comprehensive workflow later. So I would say stay tuned, because we do have something to share on that front. So if we look at the destroy aspect here, I'm not going to go through the workflow. It's pretty much similar to the create, but you can see that we've destroyed 7 resources there. And if we come back into our VPC, we've lost our QA environment. So it has successfully destroyed that particular AWS infrastructure environment for us. So this is all good and great to a degree. It's very manual. There's not really a lot of input here. But you could see that you can start layering automation. You've got version controlled Terraform modules. They're part of this. You could see some potential for this, but I think we can do better than what we have here. So I've got this AWS deployments. So this is, from the Terraform perspective, identical to AWS, but it's going to create a different named VPC for us. But for all intents and purposes, it's pretty much identical from the Terraform perspective, except what we're going to do here is that we're going to leverage the GitHub Deployments API for us. So what we're going to do here is that we're going to build our Terraform creation and destruction using GitHub Deployments on a repository. So if we take a look here at we can see we've got no deployments currently listed on our repository, but we have workflows associated with deployment create, deployment destroy, and we've got 2 other workflows for Terraform create and destroy. If we take a look at this deployment create, once again, we're falling back to using a manual invocation at this point, but this is GitHub Actions. Any GitHub event that can be used to trigger it could be used to create this deployment for you. But we need to capture at least a little bit of information as to a name and an environment that we want. And here we're using the GitHub scripts. So this is an action provided by GitHub that makes it easier for you to effectively just drop a little bit of JavaScript to do some automation within GitHub Actions without actually having to go and write your own standalone action. Now, if you were going to use this at scale within say a company or an enterprise, you would probably turn this particular repeatable step into an action and use it within your workflows. But we're going to showcasing here just some down and dirty, quick access to the GitHub API to actually do our automation for us. So at least this can help you prove out a concept or do small automation steps that isn't worth the effort of actually turning into an action. So to leverage this, we need to pass in a GitHub token. And in this particular instance, we're using this Octodemo deployment token. Now, Octodemo bot is a service account that we use for automation. And I've previously generated a personal access token and stored this on the organization level. This particular deployment token is locked to only providing access to the deployments API. So it's not an overprivileged token. It's very limited in its scope of what it's being used for here. But the reason that we're using this token is that we can't use the default GitHub _ token that you get as part of your workflow, because we protect you from recursive workflows. So the GitHub _ token won't be able to trigger events which will trigger other workflows within your repository. So you have to use an external token for this. Now, in this particular case, we're using a personal access token, but you could use a GitHub Applications token, for instance, to do this as well. And then within the script, we're creating a deployment payload. So this is our own custom JSON payload. So I'm capturing the actor. So that is the login ID of the person who's triggering this workflow. And because this is a workflow dispatch, it's whoever clicks on the workflow dispatch button. I'm capturing an environment and an app name variable. And once again, these are the inputs on the workflow dispatch. So within the GitHub script, we have this object called context, which is pre-populated for us. And the context payload refers to the actual payload of the event that has triggered us. And then under that, you can see inputs, and then app environment, and app name. So we're creating our own custom JSON payload that encapsulates the information that we want to pass as a deployment. And then here, we also get this GitHub and object within GitHub script. And this GitHub object is a hydrated octokit. And this means that it's already populated using this token that we've passed in. So it's permissioned correctly. We don't have to worry about creating this and injecting our own token. And it's wired up to the environment that Actions is running in. So in this particular instance, we're running on github.com. But if this was like GitHub Enterprise, it would be an enterprise server. It would be specific to your enterprise server. And we're going to, on the repositories, we're going to create this deployment. So we specify a repository, the reference being the commit. This task is our own custom definition of what we're doing. So we've decided to call this AWS deployment. We're not concerned about auto merging. We're setting an empty context, and an empty context means that we don't need any status checks to have passed. But potentially, if you're looking at more complex automation in this space, you would specify context here being the names of the status checks that you expect to pass before this deployment can actually go ahead. So maybe you have code scanning added to your repository and you expect there to be no vulnerabilities detected as part of that code scanning. Or maybe you've got a linter or some kind of unit test report, or you've called out to a CI system. You can specify those contexts to pass before you actually are allowed to actually deploy that environment. And then there's an environment name. So we're creating an environment name based off the application name and environment that we're passing in. And this is our unique identifier for the environment. We're then encoding our payload, which is our custom payload that we've defined. And we're marking this as transient environment. And this means that we can have multiple of these environments and they'll have a workflow associated with them based on their statuses. So that's how we create a deployment. And then if we look at the Terraform create, you can see that we're now listening to a deployment event. So when these deployments are then created on our repository, we've got this event to listen to, which is the deployment event. Now, with this deployment event though, we don't have the ability to specify aspects of what we might be wanting to listen to here, but we're only interested in when we create a new environment that we want to actually execute this Terraform create. So this is where we can leverage this filtering on a job in GitHub Actions to look into the events and actually the attributes of those events. And using GitHub's Actions expression language here, we can say that the GitHub event action has to be type created for this job to execute. Otherwise, it won't execute. So on the creation event now, we're going to actually execute this Terraform creation. Now, if we remember back to the previous AWS workflow that we had, we were injecting these TF_var variables that we were communicating with the Terraform process. Now, we don't have those because we're no longer in manual deployment. But this information is encoded inside the JSON payload of the deployment event. So we need a way to extract that and then pass that back into our job workflow so the Terraform will execute as it did before. So to do that, we've got this action step, once again, using the GitHub script and the same token that we had before, which is scoped to only access deployments for this particular repository. We've got some nice debug going on up here because life's not perfect and every now and then things fail. So this gives us some ability to get a view into the context and that if things don't go to plan. But effectively what we're expecting here is that we'll have a deployment payload given to us because that's the event that we're listening to on the on. And then within that deployment, there will also be a payload underneath the payload, and we're parsing that as JSON. We're going to output those details into the action step logs, just so we can actually see this. So if things were to go wrong, at least we've got some sort of context as to the information. But depending on what you would have in your payload, you might not want to do that step. So if you had like any secrets or sensitive information, that wouldn't be something that you want to do. And then we access the deployment statuses on the deployment itself. And then, so a deployment can have a status workflow. And on this, we only want to actually execute this workflow if there are no statuses, i.e. this hasn't been deployed before, and this is a brand new deployment. So we've got some conditional logic that we're doing in here to basically make sure that we don't have any statuses present. Then we're going to add a status of in progress. And when that is then added, we're going to then export the Terraform variables that we used to have encoded up here in our workflow. We're now pulling out of our payload and using this core.export variable. We're exposing it to the rest of our workflow run. Then our steps, like we had before, are fairly much the same as we had before. We check out our Terraform modules, we set up Terraform, set up Terragrunt, and then we just blast through and apply it. Except we do have a couple of steps at the end, and these are conditional steps which then sets the states on our deployment objects. So we've got some tracking between what's actually happened with those deployment objects that we've actually requested, because Terraform could fail. If Terraform fails, maybe we want to convey that rather than leaving an environment in a pending state, for instance. So on failure, we're using the if failure and if success on these particular action steps to filter which one will execute depending on what state the whole job workflow is in at this point. And we're either adding a success or a failure context onto our deployment. So that's our nice little workflow for creating these. So let's kick that off, and then we'll pause and see if anybody's got any questions. So we're going to create a deployment. We're going to create a dev environment and using Twitch again. And if we now watch the actual workflows, we'll see these things start to kick off in order, and a chaining of events will start to occur. So our deployment's been created, and as you can see, we've now got a second workflow that's been triggered off the back of that. If we go to our AWS deployments, we can now see we've got an environment here that says Twitch dev, which was the parameters that we passed in, and we can see that it's currently in progress. If we go back to our actions, we can see that Twitch dev is still running, but we can also see that Terraform destroy was actually triggered, but has been skipped. So this particular event was triggered, but there was a check in place that stopped that from actually executing. So we'll come back to that in a moment as to what's going on there. But we'll wait for this to deploy. And that is deployed. And if we go to our AWS VPC, we can see that we now have this new VPC that was created for us. I used a different naming convention to not collide with the previous examples. So there we have.
We use that logic, Peter. So
Beg
if
your
I say I don't want to use AWS maybe, but like Azure or GCP, could I just reuse that scripts basically and exchange the cloud provider?
Yeah, but the cloud provider at this point is actually encapsulated inside your Terraform. So this is another benefit of using infrastructure as code type tools. I could swap out the module behind the scenes, and so I can still use the deployment triggers. But the cloud platform that you target is completely up to you. So this is one of the great things of like the workflows. We don't have to change everything. We don't have to debug everything. We only have to change small chunks of it to actually flip between environments and cloud providers. And if we go back to the code, we can now see that this environment is now active as well. So we've got exactly the behavior that we expect. We can create environments using the deployments mechanism. We get a correct status based on that particular approach to that environment. And so you can imagine extending this to an application where you actually deploy a container as well. So the same type of thing could be encapsulated within this type of flow and logic. So if we were to potentially create another, so if we create a QA and run that, this time, if we look at the environments here, we should see soon in this environment side, we should see a Twitch QA environment pop up. And there we do, pending. So you could expand this, you know, and have a single repository here controlling multiple environments for applications, and using GitHub constructs, we can easily switch between cloud providers or anything while still maintaining this logic that we actually have in place. On the destroyer side, if we look into the destruction aspects, so we've got this deployment destroy, which is a workflow that will destroy our environments. So this here is once again going into the GitHub environments, using the GitHub script to do this automation. This has got a little bit more in here, but you could encapsulate this in your own custom action. But we list the deployments, and if there is any deployments based on the name of, you know, so for us, this would be Twitch Dev, Twitch QA. We find all those deployments and we transition them all to a failure state. Now we've chosen failure state here as our trigger for a cleanup event. So the deployments API has a number of states that you can use. And depending on those states, you can put your own automations in, and you can potentially integrate other external systems. And by transitioning to a failure state, we have the Terraform destroy workflow, and the Terraform destroy workflow uses deployment status. So we're not using deployments as our trigger here, we're using deployment status instead. So the reason that you saw we skipped before is that we have a condition that we only execute when the state is failure. So we've chosen failure as our cleanup state. And one of the reasons why we've chosen failure here is that in our Terraform create, if we unsuccessfully create the AWS objects, we also transition to a failure state. So by doing this, we then run this Terraform destroy to clean up any partial mess that we might have in place from that Terraform create, because Terraform could fail halfway through and we could have some objects left hanging. So that's why we've chosen the failure state here as our trigger for this particular destruction workflow. And once again, we extract out the payload information within that JSON payload that is present within the GitHub deployments the deployment payload triggered on our particular status. The same destroy activities that we do with Terraform. And then at the end, when we're successful, we flag the deployment as inactive, and then we actually physically delete the deployment. So if we were to now destroy one of these environments, we've got Twitch QA and Twitch Dev. If we decide now to destroy one of those, so let's destroy Dev, so Twitch, Dev, and we're going to execute a destruction of that environment.
So Peter, I saw that you already have these manual triggers filled out. So why is there already the value in it?
Those values are the defaults that were put within the workflow. So I've defaulted those values just to make it easy for myself. But if you don't provide defaults within the workflow file, so if we take a look at the workflow file here, you can see that these are the defaults here. And so this is just like a helping hand. But if you left those empty with the required flag set to true, if I didn't provide a value for those, they'd be highlighted with a little red asterisk on them, and it wouldn't actually accept my request to actually trigger that workflow without providing a value in that. Here you can see that the destroy has been triggered, and if we go back here, you can see that dev's currently in a failure state, and upon completion of this workflow, so we can see in here, Terraform has destroyed 7 resources. And if we go back here now, we can see that the deployment is gone. So here's a nice integration. We get tracking of what environments we've created from this repository, which is something that we didn't have before. We have the ability to action a workflow and actually now connect those two pieces together. So that's a nice direction, but this isn't an app, right? Are we interested in taking a look at some apps? So let's go to Octocat generator. So we've got an application called the Octocat generator. So this allows you to build your own Octocats. It's a container that is built into a container running Jekyll. And this particular container, we need to deploy to the cloud. So using my UK Blue Peter approach, here's something I prepared earlier. And I've written the workflow, once again, using our good old trusty friend workflow dispatch. Takes a bunch of Google Cloud Platform parameters. So here we have a GCP region that we want to target. A name of the container, once again defaulting to our Octocat generator, an image tag that I've associated that I'm calling version, and a cloud app name. So this is going to deploy to a Google Cloud project using Cloud Run. We've got a job here. We've got a couple of environment variables. So this particular Octocat generator was previously built by a developer for us. They've built this and they've deployed it into the GitHub container registry. So this particular image is available to us under the GitHub container registry, demo Twitch. So our container registry is associated with our organization, and our organization is Demo Twitch here. We've got the name of the container, which is Octocat generator, and we've got the version that we're passing in, which is the tag of our image. Now, to deploy this to Google Cloud Platform, we need to put this into a Google container registry. So as part of our build process, we're going to take our Google container image and we're going to upload it to a Google container registry that we've previously created on a project that we're going to use for this particular deployment. So to do that, we need to basically pull the image down. So here we're going to use an action provided by Docker for GitHub Actions to perform authentication for us. So we're going to authenticate with the GitHub container registry. We're going to use a personal access token that is part of our automation here. Once again, this token here is controlled at the organization level. The secret is provided by the organization level, and it's constrained to only have the permissions necessary to access the Google Container Registry. We're then going to pull that image, and then we're going to apply a tag to that image. So the image that we pulled down, and we're going to tag it with our Google Container Registry name. So then that's present on the job runner. We're then going to authenticate with Google Cloud Platform. So this is a fantastic actions provided by the Google Cloud Platform themselves, which will install the command line SDK necessary for us to interact with G-Cloud. And it's going to use a secret that we have. So we've got a service account key in our project that we're going to leverage to authenticate against our Google Cloud provider account. And then we will configure Docker using those credentials that we got back and cached. And then we're going to push that to the Google Container Registry. And then after that, we're going to invoke basically a bash script that's going to do this cloud deployment for us. So it's going to use Google's Cloud Run, deploy the container, and expose it and open it up to the world so you can all access it. So that's our workflow for starting out with a deployment of this particular application. So here we can see all our parameters that we need to pass in for this. So we've got our name of our app that we want. We're going to execute this workflow, and this is going to deploy into our GCP project. So currently, here's our GCP project, just showing that we've got nothing here at the moment. It's all completely clear, and we've now invoked this workflow for us, which is going to go through all those processes. So there's a great example of, you can see that we get emojis now in our logs, which is pretty cool. Not only color, but emojis. Be super expressive.
So can you also show us then later in the logs maybe what the result looks like that we deployed, so this generator?
The result of what, sorry?
So we have this nice AutoCAD generator you talked about, but can we also then see how it looks like deployed after this?
Yes, yeah. So at the end of this, we'll get a link that we can click on and actually see it.
Nice.
The easiest thing is to actually show it in place.
And also for our listeners, so if you have any other questions, feel free to ask them to us while we wait for the logs. And we will also stay a little bit on the chat.
So here we have, this is another great thing about the logs. URLs render quite nicely for us as well. So we can click on this, and this should take us to our Cloud Run app. So if we look in our Cloud Run, we can see now that we actually have a deployment, and there's our AutoCAD generator. So we have a deployed application in the cloud, up and running and working. So that's fairly basic. That's a command line deployment. But you know, we've been talking about Terraform here. We've been doing infrastructure of code. How can we actually make this better? So we have another workflow that's available for this, which is we've called Terraform Full here. And I'm just going to kick this off, and then we'll quickly talk over what we're actually doing here. This time around, we're passing in the GCP project rather than using a secret for it. And let's call this a QA environment, and we're going to run that workflow. Now, in this particular project, we've got Terraform GCP directory in here. Once again, using Terragrunt to inject the backend. Now, before we were using AWS, this time around, we're using GCS. So we've got a storage bucket that we're putting things in, but the whole reason we're using Terragrunt here is so we can inject the environment name into the state so we can get that single repository managing multiple environments for us. The deployment here is using a module, and this time around, we're using a module that we're sharing within this organization. So I've written a GCP Cloud Run module for Terraform, which is a generic Cloud Run module. It's not specific to our Octocat generator. It gives us an element of reuse. Here we're referencing it by name, but typically you could tag that as well and have like v1, v2, so on and so forth. We're passing in a few parameters. So one of the things here is that our container is a Jekyll container, and Jekyll doesn't run on port 80 by default. So we're specifically mapping a container port as part of our deployment to Cloud Run here for us as well. And we've got a element of configuration that we're passing in, but this is all just standard Terraform approach. And this particular full workflow file, as you saw, we're using workflow dispatch for this particular demo, but any event that you can pass information on, whether it be a deployment, for instance, or any GitHub event that you could possibly imagine, you can deploy it. This time we've added a timeout because things fail and we don't want to waste action minutes. So we've specified a maximum timeout that this will run for before the workflow is terminated. Subtly different parameters because we're using a different Terraform module and that, but once again, the pattern's the same. Inject your environment variables. You could put them on the command line, but because we have multiple Terraform steps here, we set them in the environment. The typical setup approaches that you've got before, but this time we're authenticating with GCP before we actually run the Terraform steps. So we're using our credentials, we're exporting these default credentials, and this means that they're cached on the runner. But one of the interesting things is that this GitHub Actions step, at the end of its run, it has a post action step that when the run's complete, it will clean up and remove these default credentials. So if you were reusing this runner, which is not possible in the cloud, but in the case of a self-hosted runner, it would remove those credentials at the end of a run, thereby preventing a second job that might execute on that self-hosted runner from using those credentials. So there's an element of security in there. And then we're just auto-approving and deploying this container. So we ran that execution in the background. And as you can see, we've now got this Octocat generator Terraform QA that's been deployed and is available within Cloud Run to use. If we go back to the actions workflow that was executed for that full deploy, there'll be a link in the output for the apply with the website, which takes us to that. But because it's the same application, there's not really much to see there. So this is doing Terraform as a single workflow. Now you've got no ability to review. Now a lot of enterprises now, or even potentially people would like someone to review their Terraform plans before they actually go about applying them. So what I've done here is I have separated out a Terraform plan. And so this comes back to a question that was raised earlier in the session, where how do we pass information between workflows? So we're going to generate a Terraform plan, and we're going to stop after we've generated that plan. So if we look at our workflow file, all stuff that was seen before, but we basically get to the Terraform plan and we stop at that point on the Terraform side. Here I'm using a script just to generate a small metadata payload. It's nothing special, but it gives me some tracking information about the run ID, repository, commit, and reference of the actual workflow run that we executed. And then we're using this GitHub Actions upload artifacts, which is including our Terraform plan and this file that I'm outputting, which is completely optional. It could just contain our Terraform plan, but we're associating this plan with the workflow run. So you can see that we have uploaded an artifact as part of our workflow. And if we look at our workflow now, we have this artifact, this plan artifact is now associated with our workflow. So this is one way that you can share information between workflows. So what we can do now is that we can go back to our actions and we have this plan apply workflow. And if I run this, so once again, I have some parameters that I potentially want to pass in, but if we execute this, wait for this job to pop up. And in this particular workflow, what we're doing here is we have a timeout because of the potential that this could go wrong, but we're using a community provided action called action download artifact. And we're saying that there's a workflow called GCP Terraform plan, and we want an artifact called plan, and we want to extract it to this location inside our GitHub Actions runner. So this is going to go away. It's going to look up the artifact from that workflow run that we just previously did. The artifact being plan, because there could be more than one artifact associated with a workflow run output. And then it's going to extract it locally on disk. It's then going to set up Terraform, Terragrunt, and GCP credentials. We're going to do the initialization, and then we're going to show the plan, and then auto approve it and apply it. So if we look at our workflow, the get latest plan step, you can see here that we've found this plan artifact. We've deployed it, downloaded it and deployed it into a directory within our workflow. We can look into what this was going to do. So here's the contents of our plan that was previously reviewed. We're assuming that by executing this, you've actually reviewed it and validated that this is something that you actually want to execute. And we've physically applied it, and we have an environment that's deployed off the back of it. So this is a good example of how you can start to separate those workflows and actually pass information between two decoupled workflows, not necessarily having to store them within other types of data objects, just by attaching them as build artifacts. What was the in Twitch chat there?
I think there is one question. Yeah. Should I get the artifact from a specific Terraform Terraform plan run ID? Is asked by AT Gardner.
Yeah, so I've been lazy here, so that's why it works the way it does. So what I'm doing here is when I'm running plan apply in the workflow file, I'm not specifying any other data other than give me the plan of this workflow. So that what that's actually doing is just finding the latest workflow and grabbing that file. In this particular scenario, it's the easiest thing to do, and it makes sense. In more complex workflows where you might have multiple plans being generated, multiple runs of these, different parameters being passed in those instances, this action download artifacts module has more parameters that you can specify, and that allows you to lock things down to like the SHA of the commit that was used within the workflow to get the results from. This particular action step has to do with multiple lookups to actually, find the workflow, find the job runs, find the artifacts, and it can be guided using a number of extra parameters that I'm not using here to narrow that down and get what you want.
All right, I think that was it with the questions so far. So I think it was really interesting. Also, thank you from AT Gardner. Yeah, thank you for the good question. So Peter, is there like any last tips you want to give to the audience?
No, I would say get out there and have a play with GitHub Actions. It's amazingly, it still dumbfounds me on a daily basis of the crazy automation that you can do within GitHub using GitHub Actions. It's an amazing workflow type engine. If you can think of events that might trigger it, you can add all kinds of levels of automation. I'm very impressed with how it integrates with any cloud-based vendor, any products. Like, you know, we were using Terraform here today, but I've also built systems up that use Ansible. It's extremely powerful, and you're really only limited by your own imagination and the events that we allow you to trigger on, which is forever expanding.
Very good. So thank you all for being part of this session. Thank you, Peter, for this really cool demo and asking our questions. And with that, we're closing the stream. We will be on the chat for a few more minutes, but otherwise we thank you all and tune in for the next stream at GitHub.
Thanks.